Okay, so today's topic is about dynamic routing. Because in our last lectures, we have done with static routing as well as we have done with default routing. Now, the routing concept will change because in static routing, we have to manually define the route from source to destination. But in dynamic routing, automatically route will be defined by routing protocols. So today we are going to discuss about routing protocols. If you have seen my video of OSI model, then you know at network layer we have two types of protocol: routed protocols like IP, IPX, AppleTalk. That was routed protocol used to send the traffic from one port to another port. Okay, and routing protocol are used to find the path from source to destination. So that protocols like RIP, EIGRP, OSPF, BGP, ISIS. Okay, there are so many protocols. Yes, we know that RIP is now not used nowadays in 200.301 module because it is a slow protocol. Okay, because in CCNA upgraded module it was not available. So we are not going to discuss deeply RIP, but yes, we have to do some practice over RIP protocol also, because EIGRP and OSPF are used continuously in CCNP also. BGP is also using protocol. Okay, so we will discuss our topic starting with the RIP protocol. Okay, because RIP is the base. So that's why we will discuss, but practically we are not going to use this protocol in any of our project. Okay, we will use EIGRP and OSPF. So dynamic routing is the routing in which we have to work on direct network ID. Dynamic routing work on direct network ID. We don't have to work on indirect network ID. In static routing, we have done work on indirect network ID. So I don't want to waste any time. So let's start with first protocol. That name is RIP. So RIP stands for Routing Information Protocol. Okay. Routing Information Protocol is your distance vector protocol. Distance vector protocol means like it finds the path according to the distance from source to destination. Like each protocol have metric value. Metric means criteria to find the best route. Like metric means criteria, how we calculate the path, how we find the route. So RIP use the metric hop count. Hop count means, like for example, we have a design like this: router, 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 and routers are connected like this. Okay, here you are using switch, and we have one PC there. Here we are using switch and one PC is there. So if automatically finding the path from RIP, then IP addressing is done. After that, RIP will check, like if I'm traveling from this path to reach my destination, then in my way, we have one router, one hop count. Next hop is this. Second next hop is this, and reached. If I'm using this path, one next hop, two next hop, and three next hop. So RIP is using the metric hop count, and the less hop count will become the primary path. Okay, so the criteria to find the best route for like metric, you can say RIP is hop count. So the less hop count will be the primary path. Yes, but what happened if both the path have same hop count? For example, I am using router here. So second and third. So if hop counts are equal to reach destination. Like from the both paths, we have same hop count. If hop counts are equal to reach destination, then load balancing will be there. Like load balancing means both the route will installed in routing table. Both path will installed in routing table. Okay. If hop count equal, this is the condition for that. And also if hop count are equal and if AD value is same. This is also a condition. Now, what is AD? What is AD? So every routing protocol have one like trustworthiness of the router, one value from 1 to 255. So RIP AD value is 120. AD is the logical distance from source to destination. Okay. For example, hop counts are equal, but here you are using AD value 120. Here you are changing AD value manually to 100. So the route will go via this path because less AD value is for using the path. Okay. Now AD value is used because RIP using the path automatically. Now, for example, my company owner says that you have to change the path. Okay. So what to do? I am going to change the logical distance from 120 to 100, 90, 80. So we can change the path accordingly with the AD value. Okay, so that's why it is using. But if AD value and hop count both are equal, then load balancing will be there in RIP protocol. Okay. Now, RIP has 4 timers: update timers, invalid timer, hold down timer, and flush timer. Now, why RIP use timer? Because in static route, we are defining path statically. Like I'm here and I'm on the next hop, I'm on this next hop. But in this, automatically finding the path. So that's why all neighbors of RIP sending update every 30 seconds to each other. Update timer is 30 seconds. Like each router will send information to another router after 30 seconds. So invalid time is 180 seconds, same as hold down is 180 seconds. Because if router is not sending update after 30 seconds, so another router will wait for 180 seconds. Like for the update. Like for example, I am sending you hello. So I am waiting your hello response up to 180 seconds. If up to 180 seconds you are not sending update to me, then after 240 seconds, I will flush the route. Like route will be invalid after 180, but after it will take after 60 seconds in routing table. So you will see in your practical, like if your route will be down, then it will take 4 minutes to like flush the route. Yes. So timers, that's why we call it as a slow protocol, because like if the route is down, it will take 240 seconds to deny the route. So it is a slow protocol. And convergence is very slow. Just wait. Convergence is very slow. Okay, sorry, there was a call, so I stopped the video at that time, and now I have started recording again. So we were on the point that RIP's convergence is very slow. Now, what is the meaning of convergence? We need to know about it. What is convergence? So convergence is like path convergence, path convert. So when I'm giving you an example, when my primary path goes down, then router take some time to find the secondary path. Okay, for example, I have 2 paths, and my first path is my primary path because of less hop count. Okay, so any condition in which my primary path goes down, in any condition my primary path goes down, then router will take some time to find the secondary path. That time period is known as convergence. So RIP change its path very slowly. Okay, that's why it is a slow protocol also. And there is one more problem in this. Maximum hop counts are only 15. Like continue 15 hops are there, router RIP will work. But if 16, 17 router is added in this, it will not work. So there is a problem in this protocol also. And also we have two versions of like my RIP protocol. We have two versions. So I'm rearranging this. RIP has version 1 and version 2. Okay, now we are only using RIP on version 2 because version 1 is a class full protocol. Class full protocol means it is only using FLSM. Like we are not able to use subnetting, no subnetting in version 1. So if we are not using subnetting, then there is a problem of wastage of IP address. There is no summarization. There is no authentication. Like it is not secure, and it is broadcast. It has a broadcast address. It is always broadcast. 255, 255, 255, 255 is the broadcast address. After that, version 2 is a classless protocol. Classless means we can use FLSM as well as VLSM. Like subnetting can be done. Summarization is also there, but we don't need summarization because we are using subnetting. We have authentication. We have MD5 authentication. Message digest authentication. Message digest authentication means like we have a secured authentication in this, and in this multicast address is used 224.0.0.9. So in another practical, when you will do dynamic neighborship, you will work on multicast addresses also. Okay, so this is all about RIP protocol. Okay, and the syntax is router RIP. Now you don't have to like work like IP root, indirect network ID and subnet mask. We just have to write network and its direct network ID. Yes, we have to use version 2 because that supports classless. No auto summary because we don't need auto summarization. So this is the part of the syntax. So this is the syntax that we have to use for configuring RIP. Okay, so now I'm going to do the practical. Okay, so any doubt in this? Okay.
Yes, sir. Yes, sir.
Yes, Dario, any doubt?
Yeah, I don't know, but I feel like I'm confused. Maybe first do the practical, sir, and we see maybe in the practical it will be more easy to understand.
Yes, yes. Have you done with default routing and static routing?
Yes, yesterday.
Okay, okay. Then not an issue because this is the theoretical part. We need to like discuss about this. Routing RIP is easier than static routing.
Okay.
This was the theoretical part. Okay, let's move on to the practical part. You will see that it is very easy protocol. Okay.
Okay.
Okay. So this is the design. On this design, I have done only IP addressing. Like in our last design, you have done with so many IP addressing like 10.0.0.2, 10.0.0.3, this is 30.0.0.0, 40.0.0.0, 60.0.0. Only IP addressing is configured, not any single routing. Now we have discussed that the syntax of router rip is router rip network direct network ID. Direct network ID. After that, we have to write version 2 and no auto summary. This is the syntax only, okay? So we have to check our direct network on every router. Now, if we talk about router number 1, this, okay? Click on this. How many direct network it has? It has 10, 30, and 50. If you want to check in command prompt like this, you can use the command show IP route. In show IP route, it will show you with C donation that 10, 30, and 50 is the direct network. Now we don't have to work on indirect network, so just put configuration terminal. 10, 30, and 50 are the direct network, as we have seen in our syntax router rip. So I'm writing router rip. My first direct network is 10.0.0.0. My second direct network is 30.0.0.0. My third direct network is 50.0.0.0. And at last, version 2, no auto summary. So my router 1 task is done. Simple. It is very simple. Yes, Dari, you understand the concept?
Yes, sir. Yes.
Yes, it is very easy. Okay, now move on to router number 2. But firstly, you have to configure IP addressing first, okay? Because in our last video, we have done IP addressing so many times. So I don't want to large the video. Like I don't want to extend the video for the same old topics. So that's why I have made this design earlier. So do show IP route, you can check 30 and 40. The routes are configuring with C, router, RIP, network 30.0.0.0, network 40.0.0.0. Okay, version 2, no auto summary. Now same as in third router, we have to check one more thing. Some students are confused in this show IP route and do show IP route. If you are using enable mode, then command is show IP route. Okay. If you are in config mode, then command is do show IP route. Okay. Only do and show. Clear? I'm saying if you are in enable mode, then command is show IP route. But if you want to use the same command in configure terminal, then you have to put do before the command, do show IP route. I think some students don't have taken the class of basic configuration of command. Okay, so see that router RIP network 50.0.0.0, network 60.0.0.0, version 2 no auto summary. And at last router same as 20, 40, and 60. Router RIP 20, 40, and 60. So it is a very easy protocol to configure. But nowadays we are not working on this protocol because we have some another protocols that are more faster than this, that is EIGRP and OSPF. Okay, so EIGRP and OSPF are more powerful and more faster than RIP. So we are not going to use, but yes, we are starting dynamic routing, so we have to discuss this. Okay, so now click on the router, exit. Now you have configured the routing. Now after configuration the routing, now you are putting the command show IP route. You will see direct as well as indirect networks also. Now see showing 10 network as well as 50 network. Okay, as well as showing 30. But 20 is showing with R, and 40 is also showing with R, 60 is also showing with R. Means it can be ping now. First packet will fail. Okay, you can check like this. Command prompt ping 20001. Now you are checking your packet is successful. If your packets are successful, you can check pinging like this. In here, you can check successful. It's okay. Done. So now, in this case, if 10 wants to go to 20, on this side, I have 1 hope, 2 hope. On this side, I have 1 hope and 2 hope. If this type of condition will be there, I told you equal cost load balancing will be there. If my AD value is same and my hope count value is same, then both the routes are putting in routing table. This is called load balancing. Okay, now for example, load balancing is there for 20, but what if we have more router here? Okay, now for example, I have router here and I'm going to add that router. I have to change little bit my configuration in this. Okay, so not an issue. So I'm using this cable here in serial 000, and here I have to use new configuration because I'm using 50 here. Okay, now I have to 50001 is on this router, so on this router I'm going to change interface serial 001 IP address 50002. I'm doing it a little bit fast because already we have done IP addressing, no shutdown, and now on a new serial 000 I'm going to choose 100.0.0.1. Okay. Here I have already given 50 network. Okay. But that 50 is directly, that was connected to this serial. Now I have used new router here, 100.0.0.1 here. So I have to change here serial 000 and I have to negate the command because I have to put no network here. Okay, and network is 100.0.0.0 now. Exit. On this router, on serial 00, firstly I have to put no IP address, and now I'm using IP address here 100.0.0.2. Like I have chosen new range. Okay, because I have added the new router in this. Okay. Okay, now this router is already configured with routing. This router is configured with now. Wait. Show IP route 160 and already done with 160. But this is the new router. So do show IP route 50 and 100 here. $50, $100, version 2 note of summary. Now it is also configured. Okay. Now fast forward. Now I'm going to show you the old configuration. At old configuration, 20 was coming with 2 routes. Okay. Now I'm going to check the routing table. Show IP route. Now 20 is coming only with 30.0.0.2. Only 30.0.0.2. Now question is why? If I'm going from this side to this 20, why it is coming with 30? Because on this side I have hope count 1, 2 and reached. and it is already showing 1 and 2 hop count. Okay, on this side 1, 2 and 3. Now you can see in routing table 60 is coming with both the routes. Why load balancing occur on 60? Now 60 is this.
Yes.
This is 60. Now if I'm going from this side 1, 2 and then I am reaching on 60. If I am going from this side 1, 2, then also I'm going from this. So I told you in theory, if 120 AD and hop counts are equal, then what is done? Load balancing is done. Now same as they are pinging. Okay. Now they are pinging. If you want to check in simulation, then you can check if this port wants to ping with this port, it will choose the upper part, upper path. Okay, because that is the shortest path. Okay, so done with this. Now everybody is done with RIP. Okay, thank you. So I'm going to stop the recording. Thank you.